Hi everyone, Miss Shane here. This is lesson 9. We're working on equations with fractions. Materials, I did post a lesson 9 assigned notes. They're kind of guided notes like I posted before, but this time they are going to count as an assignment so that more people are motivated to do them. So please take a look at those and have them out while you're watching the video. I structured it so that you can do it on the computer, but if you want to print it out to fill it out, that's fine too. A textbook and calculator is optional. I'm going to give you all the information for the problems like I have been, so you really don't need your textbook. And then the math that's in our problem today is pretty simple, so you also shouldn't need your calculator, but it's an option for you. Today, our content objective is to be able to use multiple methods to solve equations with fractions of a whole. And our language objective is to be able to explain the meaning of a solution in the context of a problem. Now, the language objective should sound really familiar. This is something that's really important and is involved in a lot of different concepts in math, right? It's important to understand what you just found after you did all of the math, right? So that's something that we're going to continue working on. If you are using the text, physical textbook, we're on page 396. Online textbook, we are in chapter 7 still, but we're on section 7.1.4, and we're working on problem 7-39. Are we there yet? It's about the Sutton family. Okay, so the Sutton family took a trip to see the mountains in Rocky Mountain National Park. Linda and her brother Lee kept asking, "Are we there yet?" At one point, their mother responded, "No, but I can tell you we have driven 100 miles and are about 2/5 of the way there." Linda turned to Lee and asked, "How long is this trip anyway?" They each started thinking about if they could find the length of the trip from the information they were given. So Linda drew a diagram where X represents the total distance of the trip and 1 represents one whole, which is also the total distance of the trip. So she says, she divided this line into 5 sections. So in other words, she divided it into fifths. Now she knows that 2/5 is equal to 100 miles because their mom said, "We've driven 100 miles and are about 2/5 of the way there." That means that those two are equal to each other. So if we wanted to find the total, so then that's Linda's diagram. And then Lee drew 2 similar triangles where X also represents the total distance of the trip, but this time he's multiplying X by 2/5 to equal 100 miles, right? The total distance of our trip, 2/5 of that is 100 miles. All right, so these 2 diagrams should look really familiar. Linda is using a tape diagram, whereas Lee is using a scale factor. All right, so we're going to go through 2 different methods to try and figure out the total distance, okay? So let's start with Linda's. Like we said, she divided it into 5 sections. X is equal to the total distance of the trip. Same with 1, right? So if we're talking about fifths down here, right? 1/5, 1/5, 1/5, 1/5, and 1/5 are all going to add up to 1. And then up here, we're going to talk about miles. So we said that there's 100 miles up here. Once we add all the miles up together, that's going to give us X. That's why miles are on the top and fractions are on the bottom with X and 1 respectively. All right, so let's think about this. If I have 2/5 and that's equal to 100 miles, how many times can I fit this in my entire diagram before I get to the total distance? So is a total trip more than 100 miles or less? Okay, so we know it's more if we think about it, because if this is 100 miles, we still have to go higher to get to the total distance. So we need to figure out how much more. So if I were to create a bar the same size as the 2/5, I can create another one, right? So I have 2/5 here, I have 2/5 here, which is equal to another 100 miles. But then if I add a third, what happens? It doesn't quite fit. I have to cut it in half. So I had 2/5, right? Each of these bars is equal to 2/5. So I'm going to cut it in half and have 1/5 on each side. Now I have 2/5 plus 2/5, which is 4/5, plus 1/5 is 5/5 or 1. So that gets me to where I need to be. On the top, I'll have to do the same thing. So if the whole bar is equal to 100 miles, I have to cut that in half, and each side is equal to 50 miles. Now I can get rid of the stuff that I don't need, the stuff that goes over my total distance. Okay, so now I can just add up the miles that I found for each of those sections. And then I end up with a total of 250 miles. All right, so let's look at Lee's diagram. Remember, he's using a scale factor where x is the total length of the trip, and he's using a scale factor of 2/5 to equal 100 miles. So if to get from the larger triangle to the smaller triangle, we have to multiply by 2/5. To go the opposite direction, we have to do the inverse operation of what we did to go this way. So the inverse operation of multiplication is division, so we have to divide by 2/5. And when we are dividing fractions, we do KCF. So we are going to keep the 100. We're going to change the division sign to a multiplication sign, and we are going to flip 2/5 to 5/2. 2/5 to 5/2. So now instead of 100 divided by 2/5, we have 100 times 5/2. So when we set that up, we have to put 100 over 1, and then we can just multiply straight across. So 100 times 5 gives me 500, and 1 times 2 is 2. So I have 500 over 2, which is the same as 500 divided by 2, which is, of course, 250. But what did I just find? Remember, we were multiplying 100 times 5/2 to figure out x, which was the total length of the trip. All right, so to summarize, Linda's diagram and Lee's diagram, both of them, we found the same solution of 250 miles. In Linda's diagram, she used a tape diagram and she had to use addition, right? We had to add 100 plus 100 plus 50. We thought about how many times we could fit in here as a form of repeated addition. In Lee's diagram, he used a scale factor, so he used solely multiplication or division, depending on how you want to look at it with that fraction, right? Because multiplying by or dividing by a fraction is the same as multiplying by the opposite. So what if we wanted to figure that out without drawing a diagram? So we are going to use everybody's favorite thing, algebra. That's what's coming up. I will show you how to solve an equation with fractions as coefficients. So remember the numbers in front of the variable. So for instance, 2/5 x, and we will go over how to algebraically solve it now that we've talked about how to draw some models. All right, so be on the lookout for the next, there will be one more assignment for lesson 9 where I actually ask you to apply what we talked about in this lesson. So there's going to be another lesson 9 activity, and then also there's going to be a wrap up today. So be on the lookout for that, and have a great weekend.